and then we'll start the data management part. So I'm just talking about this application, cab booking system, where we have the communication happening in terms of synchronous as well as asynchronous communication. And there we have several services also. So they are doing their role accordingly. So in this case, what we have is the in front end, we have a trip management service. So that will be taking up the calls from the client devices in terms of the API calls mainly, REST API calls. And then after the trip management service will just try to get more details from the another service, that is passenger management. So there it is just trying to check more details of the customer who is actually requesting for some service. So more information about that customer will be collected. So whether that customer is part of this system and so on. So after that further verification, and then after that information is actually passed on to the dispatcher service. And there we have the communication mode that is actually asynchronous kind of communication. So in the first two services, what we have seen is it is a kind of request response communication, that is synchronous communication. But the third point what we have is the message is actually sent in the queue, and that is asynchronous kind of communication. And the dispatcher is further tries to find out the match and all that. So this is the me application, but that kind of correlation we have. So finding the suitable place where a driver may be available, and accordingly that mapping of driver and passenger is done. And then after we have the notification also being generated accordingly to be sent to the driver as well as a passenger. So that is how what the application is. And there is some problem in the diagram. So at least at one place there has to be a driver or notification instead of at both places it is passenger notification. So one of the places we should have that driver notification. So that's it. This is the diagram of the application we have. And if we check some core part of this, exactly not full code, but I have just copied that in the presentation form only. So if you check that code part quickly about this application, then we have in the beginning we are having a queue sender kind of this object we are creating, right? Because the trip management will be sending that information into the messaging system, and that will be picked up by the dispatcher. So that is one arrangement we have. And accordingly that context is being set. And then we also have the endpoint creation to talk to the passenger management. So the second point on this slide is just setting that context so that we have the endpoint details about how to talk with the passenger management service. So that is one part. And the third one is this service itself is actually acting as a kind of HTTP listener, right? So it will be observing for incoming request on port number 9090. So we have this three back-to-back arrangements for either synchronous communication or pulling some data or pushing something into the queuing system, right? So first part is just for pushing the message into the queue, we are creating a sender. Then to talk with the passenger management service, being a trip management service, creating the client endpoints. And then after, we are also going to expose this as a business logic so that someone can actually call us as the front end service. And then after, we have the trip management service starts listening on port number 9090 with this binding on line number 4. And then we are also exactly specifying that there should be the path how one can call this particular service. And there we have exactly the function. So that will be taking up the calls from the client, right? So this client, whenever calls the trip management service, so effectively we are actually making the calls to this particular method, that is pickup, and that function will be called. So the very first point in that is we are trying to talk with the uh, passenger management service. So that passenger management endpoint is already created, and there we are posting the details of the passenger. And there we have again one more method, for example, implemented on passenger management service. So that is claims. So this is again a service to service called direct, right? So this is service to service API calls example also. We can call it like that. And then we have the queue message being created by this particular trip management service. So that is actually being sent into the messaging arrangement. And for that, we have a trip dispatcher queue, which is there, on which we have a sender like trip management will be sending messages, and there can be subsequent consumers which are interested in consuming things from there, right? So that is the story till the third last line is a story of the that queue messages and how do you send that into that particular trip dispatcher. And the last part is we are just sending the message to the client, right? That we have received your information, and soon you can get some notification for that. So that is immediate response we are providing. So the last point here is actually just closing that loop. So first point is the client has made a call to book a trip, and that last part is just closing that call. And then after, there can be subsequent other notifications coming in. So that is about the first part of the application, that is trip management service. And then we have the passenger management service. So this is relatively easy. We have a listener on port number 9091. And then on this particular base path, we can have the messages coming in. So that is the function which is available on that endpoint. And exactly it is time to verify the arriving details against the user base, and all the details are being managed by passenger management service. So not more details of that you'll find, but it is just trying to add certain more parameters of that customer. So minimum parameters being passed by the passenger while booking, and some more details are fetched by this service. And then after it is again responding to the the calling process. So what was that in this case? The trip management. So trip management service will exactly get the response. So our passenger never talks to this service directly, right? Passenger management is called by trip management on behalf of the client we can call. So verification is done there. So that is the second service we have. And then we have a dispatcher service. So there we have three different kind of messaging arrangement we can say. So one is for actually receiving the message from the queue on which the trip management is sending some message, and rest of the queues. So that is just to deliver a message to the passenger or to deliver a message to the driver. So accordingly, we have a passenger management notifier or a driver management notifier. These objects are available. So two of them are a sender and one of them is a receiver. And our service, that is a trip dispatcher, stated on line number 4. So that is just listening on some event. So as and when something is happening, so it will react accordingly. So in this case, our service is actually observing this JMS consumer only, and that JMS consumer will get something in the dispatcher queue. So it will trigger a message, that is on function on message function will be triggered. and accordingly we have that matching of the driver with the nearest location of the passenger and so on. So that details will be fetched. That is a business logic completely, and policy and all that. So that's a general convention everyone knows, right? And then after we have the proper message creation with all the details that is now prepared, and the same message is sent on both the queues, that is either a passenger notify or it is a driver notify queue. So the message preparation takes all the details about the driver whereabouts and the passenger details, and that the source and destination, whatever travel details, all that, the usual stuff. And then we have two more services. So these are very simple. They are just actually notifying to the either driver or to the passenger. So they are obviously listening on a particular queue, and they are obviously of kind this GMS consumer. So they are again listening on the GMS consumer. Anything happens in the queue, so on message function will be triggered, and just it is sending the message somehow to the passenger or to the driver, and that communication endpoints whichever to be used. So accordingly that message can be thrown, whether app notification or SMS and all that. So that is all technical stuff, otherwise can be there in the real system. Here we have only the conceptual representation of the success of that. And this the same thing with the driver, no change, only the queue name is changing, right? Otherwise there is no change in the logic which is there with the passenger notification, right? So any query with this? I think easy to understand this application, and how the endpoints are actually created, and how one service is utilizing the other service through the endpoints, and how the messages are getting generated by the various services, and how they are getting consumed by the other services, fulfilling the business logic. So let us have a quick demo of this. I just need to turn on ActiveMQ first. Yes, I need to close Mosquito Broker. So we'll have 4 such windows on screen. Okay, so we need to start 4 different services on this. So I have already copied the steps. Let's quickly do this. So I'll be running trip management on this end, the top left. Okay, it is starting that. Now we can have another service, that is dispatcher. And then we have remaining two services. Passenger management, and the fourth one is driver management. So all four services are on. Okay. So top left we have is trip management. Right, top right we have the dispatcher. So it is already listening for trip dispatcher queue. And on bottom left we have the driver management. It is waiting for trip driver notify queue. And on the bottom right we have the trip passenger notify. And there is additional endpoint, but I think that is of no use. It is present there, but it is of no use. That is trip management. Oh, sorry, passenger management. No, yes, passenger management. We have the listener. Yes, that is to be used. Why? Because the trip manager will talk to the passenger management for the verification of the customer, right? So that is also there. Now let us try to initiate the call. Okay, so we are just hitting the endpoint on 9090, this particular service, and we're making a call to a pickup method. Already details have provided, right? So let us just hit this endpoint, and accordingly we'll find some more changes in almost all four terminals. So everywhere the event, whatever has taken place, so it is just picked up by all those services as per the logic we have set, right? So it has handed over the message to the trip dispatcher with a user detail, right? So here we have the user details, uh, that email ID and all, right? So that details were actually not provided in the this particular part, right? Only name, address, and contact of that person was provided. But when this particular service talked to the passenger management service, then we have more details coming in for that particular customer, right? So passenger management has provided all that details which is required extra to verify the customer. And then after, the trip dispatcher is just finding out the match, and accordingly driver is also allotted to that particular tree. So driver details all added, and then after, a trip is also created, and that goes to the driver as well as a passenger notification. So accordingly, the driver management service also receives that message in the queue. And in passenger management also, we have that details being pushed, because that was also, I think, receiving on trip passenger notify. And similarly, this was waiting on trip driver notify, right? So that was the demonstration of that cab booking application. So I expect you'll create something similar in your next practical, which is due based on the messaging system in any language. Let me stop this now. Okay, so any query? We are moving to now another unit of the course. So we have almost 2 units for this part. So we'll be taking the things one by one on various concepts related to data management in microservices. So we'll be talking about various concepts also in this, like CQRS as well as event sourcing. Then how your application design can be event driven. So that also become clear once we have completed this unit. So how you can have your event driven application design, right? And then we also have something related to the NoSQL related stuff and consistency, which are the requirements of any kind of application, whether it is a monolithic application or it is a microservice application, but how the consistency is handled differently in this case, and what level of consistency you can achieve, and what are the technicalities of that, and more details on how the transactions can be happening across your services, and how services can be using the databases for managing the data for which they are the owner of that. So all this will have in this unit. Maybe it will take some around maybe 8 to 10 sessions at least we will have. So here we have a quick overview of either you can have a database per service kind of pattern, or you can have the shared database approach. So different kind of architectures you can apply while designing the architecture of your application. And then while querying, you have various possibilities. So by API compositions, you can pull the data from various sources. And the command query responsibility segregation is also another kind of architectural concept which also can be in place, and for data movement in your system, and how you make it consistent across your application deployment line. So various possibilities are there, whether it is a Saga transaction or event sourcing, or transaction log tailing, or the application events. Through that you are able to do event sourcing and all that. And the database triggers, I hope everyone knows that. So with various possibilities, we can have data movement happening in your services which are networked together in terms of some kind of communication arrangement in the backend system. So we'll explore all of this step by step with some examples and conceptual diagrams and applications also we'll have to understand this. So whenever we are dealing with this kind of architecture, so we'll have this kind of at least 3 kind of operations possibilities. So either we are just trying to inquire something into the system, or service may be calling to another service, just like we had previously just seen that passenger service is getting a call from the trip management service. So that is just like a query call, right? It is not modifying anything during that call. Then we have a command. So a service is just asking another service to do something. right? So the passenger management, trip management service has just forwarded that message to like a trip dispatcher, right? So that just do something for this customer. So that's a kind of a command which is given from the first service to the second service on horizontal line. It was that was from trip management to the dispatcher service, for example. And as and when we have the completion of like commands or some other activities when they are getting over, so accordingly it can be reported by your system, and your services can be generating those kind of messages related to those events. So mainly we'll be encountering this three at any point of time, and your system can be reacting accordingly as and when these things are seen anywhere during the lifetime of the application. So services may actually react, not the application as a whole, but rather part of your application or services will be trying to react to this as and when something relevant they are finding on the application deployment, whatever kind of mechanism you have for carrying those messages. So queries will never change the state of your application data, whatever database we have, whether they are at a central place or they are scattered across various places. Uh, and the commands can definitely change the state of your system. And the events are generally a kind of a message which comes into the system, and no system can deny that, right? That has happened, and the system has to accept that. So these are the three different kind of operations you can find which will regularly happen in this kind of applications. So first kind of scenario what we can have to manage your data is every service can have its own database. So some of you already demonstrated something on this line in the practicals. I have seen that. So you are attaching already like SQLite or Mongo or some other databases, MySQL and all that. So you already started something on this line. So a service has its own database to handle the all the data objects related to that particular service related business logic. So in this particular setup, it is very important that how you have actually defined the context of your set of services which are sitting together in terms of part of your business domain, right? So for example, one department or maybe some two three small departments, so they are working in close coordination and they are least concerned with what other departments are doing. So that kind of bounded context we have. We'll have some more details on this a little later. So that is also a left out part to discuss about the exact scenario, and then how you can further formalize it in terms of final microservices on paper. So we'll have that case also a little later. But here I'm just referring to this bounded context briefly. So we are just trying to put things together which are relevant to each other, and there is a heavy data movement or dependencies between those processes of your business. So we are just putting a boundary on the periphery of those services, and that we call as a bounded context. And then another bounded context can have its own purview of the operations. So when you implement this something like this, then we have to also handle this like out of the bounded context kind of communications also can be happening. And then your transactions also may be spanning over n number of services, maybe at least 3 or 4 services will be touched because of this. So kind of a long-standing transaction we have. So it will go along maybe 3 or 4 services. So how do we handle that scenario? So we'll have more details on that with some diagrams and all examples. So we'll have that understanding also later on. So that's just a diagram to understand. We are this data transfer objects will be actually pulled by like REST API calls, for example, from one service or the other service. So order service can ask for the customer, or customer service can ask for the order details and so on, as and when required. But directly, any service will not be able to touch the database which is owned by a second service. So the complete ownership of that database lies with the particular service. So here we have just the same example, but with the transaction idea, which is spanning at least on two services, right? So the order table, for example, is managed by the order service in order database, and customer table is being managed by customer service in customer table in the customer database. So here we have the transaction, which is actually spanning over multiple services. So we'll have the more details on this after a few slides. This is just an example to show how your transaction can be spanning over multiple services. Then we have another idea, that is like shared database. So that is straightforward from the conventional approach, monolithic architecture you have. So every a part of your services or every part of your application is just targeting a single huge database, and that is more easy to manage because everything is at one place, and it can easily this assure that we have ACID transactions, that compliance it will enforce. So your database will have the inherent consistency, because those databases on the conventional line always provide this kind of attributes or properties what we expect, and that will ensure the consistency. But it is simply killing the advantages what we have otherwise from the microservices approach, right? And in this case, if developers are making some change, then we have to also like propagate those changes maybe to the applications if they have made certain changes. In the microservice approach, that responsibility is completely with a team only, right? But here we are just breaking that idea. So otherwise, every service has its own representation of the data, and they know exactly if any change applied there, then it is only their lookout particular to a service. So that's a simple diagram to understand shared database, and nothing new in this. So now we come to a pattern which is trying to resolve some kind of troubles which can be there in a transaction which can be spanning across like multiple services, for example, right? So how do we handle that particular scenario when your service is executed, services are executing part of the transaction, and gradually it will be like achieving the final stage and maybe fully committed. But when we commit something in the conventional database, so that is altogether a different idea, right? So our database will assure that whatever operations we have just asked for, and if it is committed, then without worrying about the subsequent immediate failure, our data will be there in a persistent way. So that's a kind of durability we have with the conventional database approach. But in this case, we have to handle a sequence of services, and they can have their own databases. So we cannot have like a single commit which will assure your transaction is true. So right, so we cannot have that guarantee until we have the final stage and the final service says yes, everything completed, and your long-standing transaction is now accepted by the application, right? Other or 4 or 5 services have done their job successfully. So just to handle that, we have this Saga pattern where we have the multiple microservices based transaction. So it is otherwise a sequence of local transactions only, and exactly how it will be doing it. So every service, as and when it does something in the context of the transaction, so step 1, step 2, and so on, performed by service 1, service 2, subsequently as many services are required. So they will do their job, but in this case they will also inject something into the system. So whatever progress they are making, so accordingly those messages or events will be generated, and they will be picked up by the next set of services which are likely to be part of the transaction, right? So this is like a chain of the events, and accordingly every service will try to react to that. That's how your long-standing transaction will be handled by n number of services. So in this case, it is also a possibility that somewhere in your transaction, or not transaction chain, but chain of services, somewhere one service is not able to complete that part of the transaction which was otherwise to be done by that service, right? So there can be intermediate failure, and that is not the intermediate failure, but that is a failure of the transaction, right? So if the service cannot fulfill something in between, then your transaction cannot proceed further. That is one part. And we are in more difficult situation now because of something else also has happened. So what can be that trouble? Anyone can respond? What can be that trouble we have? Suppose we are having a failure at a third service in sequence, and we have 2 more services to be covered. So third service says, I cannot do it anymore. So now what will happen with the transaction? Can anyone reply? We are just asking this question in terms of consistency. So what can be the remedy to this if there is something like that happens? And what else we have done while moving towards the third service in terms of the transaction steps, right? So when we go to service 3, what we must have done? We have moved from service 1 to service 2, service 2 to service 3, and so on, right? So whenever we do that first change by the service 1, so that change is already like persistent on this database, right? Whatever changes done by service 2, so they are also marked over here in persistent way. And then after it is triggering something into your another messaging arrangement, for example, or maybe the same one, and third service will pick up. But third service say, I cannot do because of any reason, your transaction fails. So what we have to do? In that case, we have to handle that scenario. We have to have a kind of rollback, right? So we have rollback in our conventional database. So things can be recovered. But in this case, we are in a different situation. So our changes are already there in the database. So first it goes to your log file, right? Write ahead log rule is always there. So write ahead log must have marked its presence in the physical log as well. And then after it must have been stored in the actual data blocks physically onto the storage device. So we have to undo all that. because our transaction is not going to succeed, right? And because of that, we have to have a series maybe of compensating transactions. So to undo that, previous part of the transaction which was not successful till the end, so we have to just recover from all those changes which are otherwise permanent on those databases which are found in sequence onto these services, right? So this solution we must have, and for that, if we just take an example, so like a food order service is creating an order, right? And the order is in a pending state, for example, till the time it is successfully completed. So a Saga kind of object can be there, which will be managing your events. So first of all, that object is just trying to contact the restaurant service, and the restaurant service will just try to pick a particular restaurant, and then after the confirmation it is generating an event, for example. And then after, once the that object receives a positive reply, and then after it can approve that particular order, or on the negative response, your order can be rejected. And all these messages will be actually known to every service which is part of your application, right? Then after your food order service, from where you initiated the service, this particular order, so that will mark the status of that as the approved one, or it can be rejected. So that's a simple sequence of these state change about the order. So it is getting created, and then it goes through a pending state, and then after it can go to either an approved state, or it can be altogether rejected. So that is how your logical flow of the operations or state change can be there with the order which is actually made to the food order service by the customer. So how exactly this will be seen in the context of this idea what we have, that is what the compensating transaction, right? So we just need to discuss more on this with some another example. I just gave this brief idea about what can be the need about the compensating transaction, and just one scenario how an order can go through the state change, and then after, maybe not today, we'll discuss about more of this with another example. So exactly what are those compensating transactions, and what is the structure of that, what can be done, what cannot be done, what are the like retriable part of your transaction which will not harm your system. So all those details will discuss in the next session. If you have any question, I'll wait for some time, and then we'll stop for today. So we'll continue from this point in the next session about the example with the compensating transaction idea. And then we will have more understanding on how do you orchestrate your this kind of Saga based transaction. So various approaches are also there. How do you handle this particular scenario? So anyone having any question? The links to all applications what I have demonstrated so far is there already on LMS. So if you want to try out those message queuing based service demonstrations, you can try that.
So ending this session now, we'll discuss further on this on Monday.